Are you a developer interested in Web3? In this video, I'm going to give you a complete roadmap to become a Web3 developer in 2022. I will tell you what you need to learn to build smart contracts and decentralized applications so that in the end, you can find a high-paid job in crypto. And at the end of the video, I will tell you about my course to become a Web3 developer. If you are new here, I'm Julian, and on Hit the Blocks, I help Web2 developers to upgrade to Web3. There is one big mistake that I see over and over. I see many total beginners without any coding experience diving straight into Web3 development. You will really struggle if you do this. Blockchain is built on top of web technologies, so you need to know web development before you start to study blockchain. More specifically, you need to learn the basics of HTML, CSS, JavaScript, and Node.js. You will also need to know a front-end framework, and I recommend React. So if you're a beginner or you already are a coder but you don't know web development, give yourself a few months to learn this. And when you feel comfortable building simple web applications, come back to blockchain. Blockchain development can mean two things: blockchain core development or blockchain app development. Blockchain core development means that you create the software that runs the blockchain network, like the Bitcoin client or the Geth client on Ethereum. Blockchain app development means when you build an application on top of the blockchain. That's what we call a decentralized application or a Dapps. For blockchain core development, because blockchain clients need to be very performant, we have to use low-level programming languages like C, C++, Golang, Rust, etc. These programming languages tend to be significantly harder than high-level languages like JavaScript and Python, and that's why blockchain core development is not for beginners. Now, the good news is that most blockchain developers don't do core development. Most blockchain developers do blockchain app development, which means they build applications on top of the blockchain. It's exactly like with web development, where most developers do not create web browsers, instead they create web applications. And for the rest of this video, I will focus on blockchain app development. Now, there is another word you need to know, and it's Web3 development. Web3 development in most cases means blockchain app development. Okay, so you know about the terminology. Let's move on with decentralized application, the kind of app that you will build as a Web3 developer. A decentralized application, or Dapps, also called a blockchain application, is an app that you build on top of a blockchain. Once you deploy it, nobody can stop it, nobody can censor it, even big corporations or governments. It's really amazing. It also has some disadvantages. For example, it's more slow and it's more expensive than a normal web application. But the technology is still new and it's going to improve a lot. There are already thousands of Dapps available today, mainly on Ethereum, but also on other blockchains. Most of these Dapps falls into two categories: DeFi and NFTs. DeFi, which means decentralized finance, is finance reinvented on the blockchain. For example, with Uniswap, you can buy and sell tokens in a decentralized way, no KYC necessary. With another project called Compound, you can borrow and lend tokens. And for NFTs, which mean non-fungible token, it's a way to create unique digital assets on the blockchain. This has been used a lot for digital art, but it has also many other applications, like for example, representing unique financial assets, membership to a group, or a certificate. If you want to see an example of an NFT app, you can check out OpenSea, a marketplace for NFTs where people can buy and sell NFTs in a decentralized way. And if you want to see even more Dapps, you can check out a website called DappRadar. You will notice one thing when you check out decentralized application for the first time. They really look and feel like a web application. And that's because for a large part, it's what they are. But not only. Let's see what is the architecture of a Dapps. At the bottom, you have a blockchain like Ethereum. This is not strictly part of the Dapps, but it's the infrastructure on which the Dapps is built. Then you have the smart contract. That's a small program that lives on the blockchain. It's the most critical part of the Dapps. It's where you put your most important data. Everything about ownership, everything that should be decentralized has to be put in the smart contract. On top of it, you have a web or a mobile frontend. The frontend is to let users easily interact with a smart contract. Users will be able to read and modify the data of the smart contract by using the frontend. Reading data is more simple, but modifying data is more complex. For this, users have to send a signed data package called a transaction. And for this, they need to use a wallet. A wallet is a software that is hosted on the client side. It has the private key of the user, which is the equivalent of a password for the Web3 world. The private key is associated to the user address, which is like a username for Web3. It identifies users. With this private key, users will be able to create transactions to modify the data on the blockchain. You can see a transaction like a post HTTP request in the Web2 world. One very important detail is that the wallet is separated from the frontend of a dApp. A dApp interacts with the wallet, but it never has access to the private key inside the wallet. Otherwise, it would be a huge security hole. Another important detail is that even though a decentralized application is decentralized, the frontend is not decentralized. The frontend is served from a backend which can be controlled by governments and big companies. But anybody can create another frontend to interact with the smart contract of the dApp. The dApp is 90% a standard web application with HTML, CSS, JavaScript, and optionally a frontend framework like React. I told you before that you have to know the basics of web dev before diving into blockchain development. Well, now you start to understand why. Okay, so now you understand what is a dApp and what is its architecture. So next, let's move on. There are so many blockchains. On CoinMarketCap, there are more than 18,000 cryptocurrencies listed. If you want to be a Web3 developer, which blockchain do you have to learn? I'm going to save you a lot of time. There is only one blockchain that really matters, and it's Ethereum. I know that this is a very sensitive topic, and in crypto, everybody has his or her own favorite crypto. But it's not the point here. I'm not an Ethereum maximalist. I'm just being very practical. I'm talking from the point of view of a developer who wants to get a job in crypto. Most of the job market is for Ethereum. That's the ultimate argument that justifies why you should be focused on Ethereum. But why is that? Well, Ethereum was one of the first so-called second generation blockchain capable of running applications on top of it. It has the first mover advantage. Thanks to this, Ethereum was able to attract a huge community of users, developers, and investors, and now you have this huge network effect. Exactly like when Facebook reached a critical size, it was very difficult for other projects to catch up. And Ethereum has reached this size. So now, having said all of this, in crypto, beside Ethereum, there are many other blockchains. For example, we have Polygon, Binance Smart Chain, Avalanche, etc. But here is the most important part. Most of these blockchains are based on the technology of Ethereum. By doing this, they can leverage the pool of developers who already know Ethereum, as well as the pool of users who already use the tools of Ethereum, like MetaMask. And finally, you will hear people telling you that Ethereum is not scalable, contrary to many other blockchains, and you shouldn't use Ethereum. A lot of these Ethereum competitors sacrifice decentralization for scalability, and that's why they cannot really be considered true blockchains. Ethereum is one of the very few blockchains that is developing a scalable, secure, and decentralized blockchain. That's the future update of Ethereum, called Ethereum 2.0. And yes, it's taking a lot of time to come out, but it's because they are doing the real thing, and it's difficult, but they are on the right track. So now you know that you have to focus on Ethereum. But what do you have to know about Ethereum exactly? There is a good news and a bad news. The bad news is that Ethereum is really complex. The good news is that you don't have to know everything about Ethereum as a Web3 developer. Remember, we are talking of how to become a blockchain app developer, not a blockchain core developer. You need to separate Ethereum, the protocol, from Ethereum, the implementation. As a blockchain app developer, you need to know the protocol, but you don't need to know the implementations like Geth or Open Ethereum. Another important thing to know is that at the moment, Ethereum 2.0 is not fully released yet. And as far as blockchain app developers are concerned, building apps on Ethereum 1 will be very similar to building apps on Ethereum 2.0. Alright, so now let's dive a bit more into the details. The Ethereum protocol is based on the blockchain technology. That's why you need to learn blockchain first. And to learn how blockchain work, I recommend the book of Andreas Antonopoulos called Mastering Bitcoin. So I know that I just told you to focus on Ethereum, but this book, Mastering Bitcoin, is the best explanation of the blockchain technology that I have ever read, so I strongly recommend it. Next, let's continue with what is specific to Ethereum. On Ethereum, we have addresses that act like identifiers. You need to understand how addresses are generated and which data is associated to each address, like the Ether balance. There are two kinds of addresses, EOA and smart contract addresses, and it's important to know the difference. Then you need to know what is the data structure of the Ethereum blockchain. It's a little bit more complex than Bitcoin. Then you need to understand what is a smart contract. Smart contracts are small programs that runs on the Ethereum blockchain, and it's what makes the Ethereum blockchain so powerful. Another related concept is the EVM. The EVM stands for the Ethereum Virtual Machine and is the part of Ethereum that runs smart contracts. You need to understand how the EVM executes smart contracts. And after that, you need to understand the API of Ethereum. The Ethereum API has many endpoints, but there are two that are really important. One that allows to read data from the blockchain and another one that allows to modify data. So I encourage you to check out the documentation of these endpoints to understand what are the parameters required. Related to these two endpoints is the concept of a transaction. A transaction is a signed data package to modify the state of the Ethereum blockchain. It's used to execute smart contracts and also to transfer Ether between addresses. You need to know what are the different fields of a transaction. When you build a blockchain app, the most important part is the smart contract. Smart contracts are small programs that live on the blockchain. Usually they are quite small, a few hundred of lines of code to a few thousand, rarely more. These programs are very different from normal programs. Once they are deployed, you cannot change their code. We say that their code is immutable. However, the data is not immutable. You can still change it. Contrary to a normal program, it costs money to change the data of a smart contract. And the more complex your code, the more money it costs. So we try to simplify our code to lower the execution cost. That's called gas optimization. It also takes time to change the data of a smart contract because you need to wait for a transaction to be mined, which takes about 15 seconds on Ethereum. With a smart contract, you can move money natively. This is why smart contracts are so powerful. With a normal program, you will have to integrate with a payment service like PayPal or Stripe, but you need to have a permission to do this and you are constrained by the API. With a smart contract, you can write any logic you want for moving the money. In terms of security, it's almost impossible to hack the core blockchain protocol. That means that if a transaction is sent to move money from an address to another one, it's impossible to hack this and change the recipient address. However, it's possible to introduce a bug in the code of a smart contract and you will have hackers who take advantage of this. There are a couple of programming languages for smart contracts, but the most popular is called Solidity. So you will need to learn the Solidity programming language to create smart contracts. Even though the syntax of Solidity looks very similar to JavaScript, Solidity is very different from JavaScript. For example, in Solidity, you have to declare the types of your variables, which is not the case in JavaScript. You also have to do some memory management in Solidity, whereas in JavaScript, it's all managed for you by the language. Solidity is also much more limited compared to JavaScript. That's why we avoid to do complicated things in Solidity. A great way to experiment with Solidity is to use Remix, an online IDE for Solidity. With Remix, you have nothing to install. You just load the website and you can start writing and running Solidity smart contracts right away. Once you know how to use Remix, the next step is to learn how to use a smart contract framework for more advanced projects. There are two popular smart contract frameworks. They are called Truffle and Hot Hat. Truffle is a bit easier to get started with and has more integration and plugins, but Hot Hat has become more and more popular, especially for more senior developers, and a majority of blockchain projects now use Hot Hat instead of Truffle. I would recommend to learn the basics of both. They're quite easy to learn, and once you have more experience, you can decide to settle with one or the other. Both of them are written in Node.js and you can install them very easily with npm. When you develop smart contracts, you also need to use a local blockchain completely isolated from the real production network. Hat has its own built-in local blockchain called Hat Network, and for Truffle there is another tool built by the Truffle team called Ganache. These local blockchain all come with accounts preloaded with fake ether to do tests very easily. So you will need to learn how to use these two local blockchain on Hat and Truffle. They're quite simple, it's just a CLI tool that you start in your terminal and that's it. And the next step is to learn how to test your smart contracts. This is very important because once we deploy a smart contract, we cannot update its code. So we need to make sure that everything works well before deployment. The way to test smart contracts on Hat and Ganache is quite similar. You write test files that look similar to what you would do in Node.js with the same syntax as Mocha and Chai. There are also some very useful testing libraries like OpenZeppelin test helpers. Once you know this, the next step is to learn token standards like ERC-20 or ERC-721. These tokens are financial assets represented by smart contracts on the blockchain, and they are really at the core of many blockchain applications. ERC-20 is for fungible token, which means asset that can be exchanged against any other, like a dollar bill, for example. ERC-721 is for non-fungible assets, which means asset that cannot be exchanged for another one, like art, for example. It's important to know not only these token standards, but also how to implement these token standards in a Solidity smart contract. And for this, instead of writing your own implementation, it's better to use OpenZeppelin, a Solidity library with battle-tested implementations for ERC-20 and ERC-721 tokens. So that's it for the basics of smart contract and Solidity. And next item on your to-do list is to learn how to deploy smart contracts on public networks. Besides the local development networks, there are also what we call public testnet, which are public blockchain networks that are more realistic testing ground compared to a local blockchain like Ganache. These public testnets are completely separated from mainnet, the real production network of Ethereum, so you can use them safely for development. To do your test on this public testnet, you need to obtain some testnet ether, and you can do this with a tool called a faucet. Each public testnet has its own faucet. It's quite simple to use. When you use public testnet or mainnet, you will also need a tool called Etherscan. Etherscan is what we call a blockchain explorer. With Etherscan, you can verify that a transaction was mined on the Ethereum blockchain. You can use Etherscan both for mainnet and public testnet. When you want to connect to a public testnet or mainnet, you need to run your own Ethereum node. But it's not easy. You need a very powerful machine and some expertise on how to run an Ethereum node. But instead of doing this, it's much easier to use an API service for blockchain. There are quite a few like Infura, QuickNode, Alchemy, or Moralis. To use these services, all you have to do is create a free account and they will give you an access to a web API with which you can interact with Ethereum. Okay, so once you learn how to deploy your smart contracts, the next item on your to-do list is to build a front-end. If you just have a smart contract on the blockchain, the only way to interact with it is with the command line. That's why we also need to build a front end to let our end user interact with our smart contract. The combination of the smart contract plus the front end is what we call a Dapp, or a decentralized application. The front end can be a mobile app or a web app, but in most cases it's a web app. The front end of a Dapp is 90% similar to a web application with HTML, CSS, JavaScript, and optionally a front-end framework like React. But on top of this, there will be two challenges specific to the blockchain: the integration with the blockchain and the integration with the wallet. For the integration with the blockchain, you have two libraries at your disposal: Web3.js and Ether.js. These days, Ether.js is getting more popular, but I still recommend to also know Web3.js to make yourself more marketable on the job market. For the integration with the wallet, it's up to you to decide which wallet you want to support. But you should support at least MetaMask, which is the most popular wallet for Ethereum and other Ethereum-based blockchains. MetaMask is a Chrome extension. It injects itself in your JavaScript code when the web browser loads the front end of your Dapp. You can do the integration with MetaMask by using your own JavaScript code, and that's what I would do as a beginner to learn. Or you can use a library like Web3 React or Wallet Connect, and that's what I recommend in production. And with these libraries, you can also support other wallets very easily. And after you learn all of this, congrats, you will know how to build dApps on Ethereum. But if you want to be even more competitive on the job market in crypto, you will need to specialize, and that's what I will talk about next. There are a couple of ways you can specialize as a Web3 developer. First, you can become a smart contract security specialist. This is where you will find the highest salaries in crypto. For senior position, it can go up to $300,000 a year, and in some rare cases, I've even seen some insane salaries of up to $1 million. Yes, $1 million, completely insane. To be really good at smart contract security, you need to know Solidity really well, including assembly, a low-level language within Solidity. You will need to know in details the Ethereum virtual machine, also called EVM. You will also need to know about gas optimization. And of course, you need to know all the typical security vulnerabilities in a smart contract and how to fix them. Another way you can specialize is in DeFi. DeFi, or decentralized finance, is one of the main use cases for Web3 applications. And if you want to have a list of important DeFi projects, you can check out a website called defipulse.com. I recommend picking a few protocols and doing a deep dive in how they work. But beware that many DeFi projects are copy-paste of others, so don't waste your time learning too many. Focus just on some high-profile DeFi project that had been there since the beginning, like Uniswap or Compound. And beside DeFi, the other big application for Web3 apps is NFTs. To become an NFT expert, you need to study how to make an NFT collection, how to handle the metadata, and how to mint new NFTs. You can also check out generative art, which is a technique to generate art with code. And you can also study how to build an NFT marketplace like OpenSea. And a last way you can specialize as a Web3 developer is to specialize in the front end. You will need to focus on the different UI UX challenges that are specific to Web3 application, especially when it comes to integrations with wallets. And once you do all of this, you will be ready to find a full-time job in crypto, get a nice salary, and work on something interesting. So you can learn all of this for free. There are resources for free on YouTube, on my channel, on Stack Overflow, on Twitter, on Discord, etc. But if you value your time and you are willing to invest in your education, you can take my courses and make it way faster and easier to become a Web3 developer and get a full-time job in crypto. I have a course for beginners called 6-Figure Blockchain Developer. And I also have other courses that are more advanced, like a course on DeFi and another one on NFT. So go check out the curriculum of my courses. I put the links down below. And no matter if you take my courses or not, welcome to the Web3 family. This is just the beginning of your journey. That's it for today. Bye.